4.2, day 3, talking about statistical significance. So when we get done with an experiment, we want to know, are our results going to prove something right or wrong? So, the first blank, in an experiment, researchers usually hope to see a difference in the responses that's so large that it's unlikely to have happened just by chance variation, just by random chance. So, like when I conducted the memory game experiment, I wanted to see a difference in the memory group versus the control group so big that it couldn't have just been by chance. In general, we can just use the laws of probability, which describe chance behavior, to learn whether the treatment effects are larger than we would expect to see if only chance were operating. And if they are, we call them statistically significant. So the results we saw today with the distracted driver activity, that was statistically significant because we had a low, just a little over 1% chance of getting 12 or more bad drivers in the cell phone group if it was just random chance for bad drivers being in that group. So an observed effect so large that would rarely occur is called statistically significant. A statistically significant association in data from a well-designed experiment does actually imply causation. So if we can prove that something is extremely rare in a well-designed experiment, that does imply causation. How rare does it have to be? That depends on the person. Some people believe it has to be 5%. Some people believe it has to be below 1% chance to happen. But then we can prove it actually implies causation if it's statistically significant. So let's go back to the caffeine experiment. So if caffeine really has no effect on pulse rates, then the average change in pulse rate between the two groups, whether it's caffeine or the group that got no caffeine, that should be exactly the same. So the changes should be exactly the same, like distributed randomly, they'd be the exact same. Scroll down here. So, however, because the results will vary depending on which subjects are assigned to which group, random assignment, the two groups will probably be a little bit different at least. So whenever we do an experiment and find a difference between the two groups, we need to determine if this difference could be attributed to the actual chance variation in random assignment, or if there's really a difference in effect of the treatments. So did we somehow just get all the caffeine tolerant people in one group, or does caffeine really make a difference between the two groups? So how can we determine if our results from an experiment are statistically significant? Well, we've done this a couple times already this year. We did the distracted driving activity. We also did the hiring discrimination activity. Remember that one with the pilots, and they hired 5 females and they thought it was discrimination, and we proved that it wasn't because we did a random simulation. So far, we just conduct a simulation that models truly random outcomes, whether we do it with cards or a random number generator or whatever. So that's called a randomization test. So we conduct a randomization test and we see what the likelihood of that would be happening just randomly. So we use our results to conclude whether it's statistically significant or not. So in summary, you do an experiment, you see what the chances are that result would happen just by random occurrence, and if it's below, let's say 5% or 2%, if it's really rare, then that's what's considered statistically significant. And we saw that in distracted driving. It was really rare that we got 12 or more bad drivers in the cell phone group if it was just by random chance. And we actually looked at that in the hiring discrimination activity at the beginning of the year too. So is it statistically significant or not? Then you can enjoy the comic. That's for you. That's all for these notes. I'll see you in class.